Hello everyone, welcome back to Mathematics for Engineering 3. Today we are going to be talking about the inverse Laplace transform techniques. Okay, so in the previous video we looked at how to use the basic formulas to do the inverse Laplace transforms, right? But today we're gonna look at the techniques for the inverse Laplace transform. Guys, if you remember, when we do the Laplace transform, we do have lots of techniques, right? To the Laplace transforms. And the techniques that we're going to be looking at today is just the inverse of those techniques. Okay, so it's nothing really new today. Okay, so it's the thing that we have seen before, but it's just the inverse of what we have seen before. Okay, guys, so let's start here. The first technique would be the first translation, right? When we did the Laplace transform, the first technique that we looked at was the first translation, right? Which means that if you have the Laplace transform of e to the at ft, the Laplace transform of that, you just need to find the Laplace transform of ft, right? The Laplace transform of ft, and then you shift s to s minus a, right? Right? And that is the same as the Laplace transform of, f, the big F of s minus a. Okay? I think this one you already familiar with because we looked at that in the second video of this chapter, right? So if you want to find the Laplace transform of e to the at ft, that is the big F. The big F is the inverse. Guys, don't forget the big F here is actually the Laplace transform of ft. Okay, and then you substitute s with s minus a. Okay, that's the first translation. It's the shift from s to s minus a. Okay, so shifting. And the first technique for the inverse Laplace transform would be the same technique, but it's the inverse. Okay, so if you want to find the inverse Laplace transform of f, the big F, s minus a, that would be e to the at ft, right? But guys, don't forget ft is actually the inverse Laplace transform of fs, right? Because guys, don't forget L little f is big F, so L inverse of big F would be little f. Okay, very simple, right? So you won't have this formula in the exam. You only have this one, but you can just push this L here to L inverse here, so you get the L inverse and you get e to the at ft, and ft is actually the inverse of the big Fs, right? Cool. So example, find the inverse Laplace transform of 1 over s minus 3 to the 5 to the 5. Okay, so that one first, you probably see that it's actually from what is it, 4 fact divided by s minus a to the 5, right? Right, it's actually the inverse, the Laplace transform of t to the 4, right? And then you shift it from s to s minus a. Makes sense? So for this one, it would be Laplace transform of 1 over s minus a to the s minus 3 to the 5, and then I multiply 4 fact divided by 4 fact, okay, to both numerator and denominators. Okay, so what I have here would be, and then I pull 1 over 4 fact out, I would get Laplace transform of 1 over 4 fact divided by s minus 3 to the 5, right? Right, and that is the same as, what is it? It would be 1 over 4 fact, and this guy is actually e to the 2t, e to the 3t Laplace transform of 4 fact divided by s to the 5. Does it make sense? Because guys, look here. The Laplace inverse, Laplace transform L inverse of the big F s minus a. In this case, is f minus s minus 3, right? S minus 3. In that case, you can pull this 3 out, okay? And that's going to be e to the at, e to the 3t, okay? And then you find the inverse of just the s without the 3, okay? Okay, so basically it's pretty much the same as to pull this 3 out, and you get e to the 3t, and then you just find the inverse Laplace transform of the original one before being shifted. Okay, before being shifted. Okay, so here you would have 1 over 4 fact e to the 3t, and then L inverse of 4 fact divided by s to the 5. That would be t to the 4, and that's it. Okay, that is quite simple. Okay, does it make sense? Okay, so the next one, this one, it looks pretty much like 1 over s squared plus k squared, right? It will be k divided by s squared plus k squared, but this s is shifted to s minus a. Okay, in this case it's s plus 1, but guys, s plus 1 is actually s minus 1, right? So firstly, we need to change these to 1 over s plus 1 squared plus square root 3 squared, right? I want k squared, so I change 3 to square root 3 squared, and then I multiply up and down by square root 3, so that I can get k s squared plus k squared. Okay, and after that I pull 1 over square root 3 out, so I get L inverse of square root 3 divided by s plus 1 square plus square root 3 squared. Okay, and guys, don't forget that this guy is actually s minus 1. Okay, and you can pull this minus 1 out of the inverse, right? Using the inverse, the first cancellation technique. So you would have 1 over square root 3, and then you get e to the minus 3, e to the minus t. Okay, and then you get L inverse of square root 3 divided by s squared plus square root 3 squared. And that will be 1 over square root 3 e to the minus t. And this would be psi square root 3. That's it. Quite simple, isn't it? First, you need to be able to identify the original form. And then you shift it out, right? You pull this this minus 1 out of the Laplace transform using the first translation. And then this reduces to the form that you already know. Okay, next, this example is quite simple as well. Here it's the form of s divided by s squared minus k squared. Okay, so if you look at this, you would need to look at this guy as one s, and this guy is the other s. Okay, it's a big S, basically, the big S. Okay, but guys, don't forget, S plus 2 is actually S minus 2. Okay, Okay, so this guy is actually like s minus a. You look at it as a big S. Okay, so this guy, you can pull this minus 2 out. Okay, it will become e to the minus 2t. E to the minus 2t, and then you just need to find the Laplace transform of. Okay, let me write it a little slower. It would be here s minus minus 2 divided by s minus minus 2 squared minus 2 squared. Okay, and then I shift, the s is being is the s was shifted, right, from s to s minus minus 2. So I pull s minus a out, right? This guy can be seen as a. So I pull the a out. Guys, look at the theorem. Basically, you can pull this a out. It's gonna become e to the at. Okay. Here, when you do the Laplace transform, you put e to the at in there, and then you shift this to s minus a, right? When you do the Laplace, the normal Laplace transform, you multiply e to the at to ft, and then after the transform, it needs to be shifted from s to s minus a, right? And when you do the inverse, if it's shifted from s to s minus a, if you want to pull this a out, it needs to be e to the at. Okay. So here, I'll pull this a out. So it would be, what is it? E to the minus 2t. And then I just need to find Laplace transform of s divided by s squared minus 2 squared. And that is e to the minus 2t of cos of 2t, and that's it. It's very simple. You need to be able to tell the original form. For example, this one, the original form is s divided by s squared minus k squared, right? But you look at s plus 2 and s plus 2 as s. Why? Because it was shifted, right? It was s before and then it was shifted to s plus 2. Right? So when you want to do the inverse, you need to shift it back, right, to s, like that. Right? And when you shift it back, you can get e to the minus 2t out, right? If you do the Laplace transform, you multiply the little f with e to the at, right? It shifted to the big F of s minus a, right? If you do the inverse, okay guys, let me write it down here. When you do the e to the at, ft, when you do the Laplace transform, you shift it to f of s minus a, right? So whenever you see s minus a, you shift it back. You can eliminate this minus a, and it's gonna be e to the at. Okay, next question. This one. Find the inverse Laplace transform of s plus 2 divided by s minus a squared plus 9. So guys, this one, you need to somehow look at it as s divided by s squared plus k squared, right? S divided by s squared plus k squared. But here, if you look here, I'm gonna change it to L inverse s minus 2. Because I want it to be the same s, right? But here, it fixed to s minus 2. So up there, it needs to be s minus 2 as well. But if I want to make it from s plus 1 to s minus 2, I need to plus 3. Right? And then here, it would be s minus 2 squared plus 9. Makes sense? Because s minus 2 plus 3, that would be s plus 1. Okay? These two terms are equivalent. Okay? And then because the L inverse is the linear operator. So what I have here would be L inverse of s minus 2 divided by s minus 2 squared plus 9. Plus L inverse of 3 divided by s minus 2 squared plus 9. Guys, 9 is actually 3 squared, isn't it? Okay, so this guy is actually s divided by s squared plus, I'll just use the big S, okay? S divided by s squared plus k squared. That is the form when you look at this guy as s. Okay, s divided by s squared plus k squared. And this guy is actually k divided by s squared plus k squared, right? When you look at this as s. Okay, so you need to shift it. So after the shift, you get that is e to the 2t, right? S minus a e to the at, s minus a e to the at, s minus 2 e to the 2t. Okay, so e to the 2t, L inverse of s divided by s squared plus 3 squared. Right? You shift it back, and here you get e to the 2t as well, and L inverse of 3 divided by s squared plus 3 squared. And that would be e to the 2t cos 3t plus e to the 2t sine, is it sine? 1 second, I don't remember. Go and look back at the table. So here, the one with s is a cos, this one is sine. So we would have cos 3t and sine 3t. That's it. Very simple. Next example, this one. It's not clear how s is shifted. It's not clear, right? Because it's not like this one that you already have s minus 2 squared, and then you know that s is shifted to s minus 2, right? But this one is not very clear. So the technique that you need to use is the perfect square. Okay, so you need to change this guy, s squared plus 4s plus 13. So you get s squared plus 2x s plus 4 plus minus 4 plus 13, and that is s squared plus 2s plus 2 squared, right? And then here that would be, what is it? Minus 4 plus 13, that's plus 9. So this guy is actually s plus 2 squared plus 9, right? Guys, here you can look at this as a squared plus 2 ab plus b squared, okay, which is a plus b squared. Okay, that's the formula for the perfect squared. Okay, so this guy can be rewritten as 13 divided by s plus 2 squared plus 9. Okay, and then guys, you can see right now that s is shifted, right? Is shifted with s minus 2. Okay, s minus a, right? So this guy right now is a. S minus a, s minus 2. So this guy 9 here is actually 3 squared, right? So right now you know the form. The form is actually k divided by s squared plus k squared. Okay? Okay, so what you need to do is that L inverse of 13 divided by s plus 2 squared plus 3 squared, and then I multiply 3 and 3 here. Okay, and then I pull this guy out. So I get 13 divided by 2, L inverse of 3 divided by s plus 2 squared plus 3 squared. Okay, and I shift these 2 out, it's s minus 2, right? So I would get 13 divided by 2 e to the minus 2t, and then inverse Laplace of 3 divided by s squared plus 3 squared, and that would be 13 divided by 2. Okay, just write here. 13 divided by 2 e to the minus 2t of psi of 3t. Okay, that will be psi of 3t, right? Number divided by s squared plus 3 squared. And that's it. Very simple. Okay. Okay. Guys, next example. This one is quite similar. Okay. So I'll let you guys try it yourself. And then we will do this in the on-site class. Okay. So we will try to do this in the on-site class. Cool. Okay. Okay, guys, for this question, it's quite clear here that s is, it was shifted from s to s plus 6, right? So we somehow want to shift it back to s. Okay, so I will rearrange this term. Okay, 3s plus 4. I'll change it to 3s, and then I plus 18, and then I minus 18 and plus 4. Okay, if I plus minus 18, it doesn't change anything, right? So here it will be 3s plus 6 minus 14. Okay, 3s plus 6 minus 14. So this inverse Laplace becomes L inverse of s plus 3s plus 6 minus 14 divided by s plus 6 to the 5. Okay, so guys, right now we see s plus 6. We know that is actually s minus 6, right? So it shifted s to s minus a, right? So we want to shift it back. So using the first translation technique, so we get e to the minus 6t, L inverse of 3s minus 14 divided by s to the 5. See, we shift it back. Okay, and after that is now quite simple. It will be L inverse of 3 divided by s to the 4 minus 14 divided by s to the 5, and that will be e to the minus 60. It would be 3 L inverse of 1 over s to the 4, and then minus 14 L inverse of 1 over s to the 5. Okay, and you want to find the inverse of 1 over s to the 4 and 1 over s to the 5, right? You need to multiply this with 3 fact divided by 3 fact, and here 4 fact divided by 4 fact, right? And then I pull the constant out, so I get e to the minus 60. Here I will get 3 divided by 3 fact, L inverse of 3 fact divided by s to the 4 minus 14 divided by 4 fact, L inverse of 4 fact divided by s to the 5. Okay, and that would be e to the minus 60. Here 3 fact is actually 6, right? So you get 1/2 of L inverse of 3 fact divided by s to the 4. That would be t to the 3, right? Minus 4 fact. 4 fact here is actually 4 times 3 times 2 times 1, right? So here, if I change it here, it will be 7. So it would be 7 divided by 12 L inverse of 4 fact divided by s to the 5, that would be t to the 4. So we would have that here is e to the minus 6t, 1 half 3 to the 3 minus e to the 6 3 7 12 e t to the 4, and that's it. Okay, actually you can just end here. Okay, you don't need to actually write it here. You should just end there. I think it looks, equally ugly. Okay, it looks, yeah, equally ugly. Right? It's not beautiful at all. Okay. Okay, and that is the first translation. Guys, again, if you have ft, you can find the Laplace transform of ft, right? But if you have e to the at ft, when you find the Laplace transform, you need to change it to s minus a, right? You need to shift it to s minus a, right? That is the Laplace transform. But if you have f of s minus a, if it's a function of s minus a, for example, like that, like this, like that, you can change it to s, from s minus a just to s. Okay, using that, you can pull e to the at out, and that is the first Laplace transform technique. Okay. Okay, guys, the next technique is the second translation. Okay, guys, we won't study the transform of the derivatives of transforms. Okay, that is not included in the syllabus. Okay, so we're gonna be looking at the second translation. If you remember, when we do the Laplace transform, we transform e Laplace transform of f t minus a ut minus a. Here is the unit step function, if you remember, right? F of t minus a ut minus a is e to the minus as Laplace transform of ft. Okay, okay. So the inverse would be similar, right? You take the inverse, you change this to this side, it's going to be L inverse. L inverse of this, okay, would be this guy, okay. And to compute this one easily, you just need to take the Laplace inverse Laplace transform of the big F, and then you change from t to t minus a. Okay, why? Because here, guys, you know that f L inverse of t ft is fs, right? Right. Okay. Sorry, it's the other way around. My bad. L inverse of ft of fs is ft, right? L inverse of the big fs is little ft. So if you want f of t minus a, it's pretty much the same as first find L inverse of the big fs, then you get ft, right? And then you change from t to t minus a. Okay, so again, guys, whenever you want to find the inverse Laplace transform of e to the minus as big fs, that would be this guy, because this is actually from the formula, right? From the table. Guys, you won't have this formula in the exam. You don't have it in the exam, but you do have this one, right? But it's it's interchangeable, because you just need to change your L here and put L inverse here, right? Right, and this guy is actually fs, right? So you basically have this formula automatically. Okay, so this formula is actually not needed. That's why it's not provided in the exam. Okay, so if you want to find L inverse of e to the minus as fs, that would be ft t minus a ut minus a. But ft minus a is actually L inverse of the big fs, and then you change from t to t minus a. Okay, it's the same thing. Okay, guys, let's look at this example. So I want to find the inverse Laplace transform of e to the minus 7s divided by s to the 4. Okay, guys, look here. Look here. E to the minus as fs. So here, this guy would be e to the minus as. Okay, you can write this in terms of e to the minus 7s and then 1 over s to the 4. Okay. Okay. And in that case, you would have that it is actually the big F s would be 1 over s to the 4. Okay. Okay. And a is actually 7. Okay, just compare, guys. E to the minus as, e to the minus 7s, which means that 7 here is actually a. Okay, cool. And guys, what is L inverse of the big fs? What is L inverse of the big fs? You need to find L inverse of, what is it? 1 over s to the 4, right? I multiply it by 3 fact and 3 fact. Okay, we have done that many times, so okay, I'll do it quite quickly. So I pull 1 over 3 fact out, so I get L inverse of 3 fact divided by s to the 4, and that will be 1 over 6 t to the 3. Okay, that would be ft. Right, that will be ft. Okay, so if you want to find L inverse of e to the minus 7s divided by s to the 4, that would be ft minus 7, right? T minus a, don't forget, guys, t minus a, that will be t minus 7, ut minus 7. Okay, but ft is 1 over 6 t to the 3, so ft minus 7 would be 1 over 6 t minus 7 to the 3, and then t minus 7, and that's it. Okay, guys, I know if you look at it the first time, it could be confusing, but if you keep doing exercises, you keep looking at more examples, it will get clearer and clearer, because actually the idea is quite simple, right? You have the Laplace transform, and then you have the inverse, you transform it back to the original form. Okay, guys, to sum it up here, here this one, if you compare it with this form, it seems like this guy is e to the a, this guy is e to the minus as, right? E to the minus as, e to the minus 7s, which means that a is actually 7. Okay, and the rest would be the big fs. Okay, the rest would be the big fs. Okay, so L inverse of the big fs would be L inverse of 1 over s to the 4, right? But you want to find the L inverse of 1 over s to the 4, you need to multiply it by 3 fact divided by 3 fact, so that you can take this L inverse as 3 to the t to the 3. Okay, and from the theorem, it says that L inverse of e to the minus as fs is actually this guy. Okay, which is equivalent to this one, right? You have this formula in the exam. Okay, so in that case, you just put it down here, and you already have ft, right? So you just substitute, change t to t minus 7, and that's it. Okay. Okay, next example. This one, oh guys, again, this one, if you want, you can write it down like that. L inverse of e to the minus 7s divided by s to the 4, it can be written as 0 if t is less than 7 and bigger than 0. Okay, and 1 over 6 t minus 7 cubed if t is greater or equal to 7. Guys, you remember this function, right? This function is 1 when t is bigger or equal this value, which is 7. Okay, and it's 0 otherwise, right? It's a unit step function. If you don't remember, go back to the third the part 2 of the second section. Okay, guys, this example first I'll just I'll just write like that. L inverse of 2 over s cubed minus L inverse of e to the minus 2s over s cubed plus 4 L inverse of e to the minus 4s divided by s plus 2. Okay, use the linearity, right? The linear property of the inverse Laplace transform. And this guy is quite simple. 2 is the same as 2 fact, right? So this guy is actually t squared. Very simple, right? This guy, see, is e to the minus 2s. Okay, I'm not gonna do it slowly like this, okay? It's too slow. I'm not gonna do it like that. I'm gonna do it quite quicker. So the way to do it is here, it would be minus, and then guys, here, we just need to look at the inverse Laplace transform of 1 over s to the 3, and then you need to shift from t to t minus a, which is minus 2. Guys, don't get confused with the minus and plus, okay? Here, it e to the minus as, right? It e to the minus as, guys, see here. It e to the minus as, which means that a is actually 2. Okay, and when you shift, you need to shift t to t minus a. So I need to shift t to t minus 2 because our a now is 2. Okay, see, it's quite easier, right? You just shift it. Okay, so in plain text, in human language, if you see e to the minus as or e to the minus as, you can pull it out, and then you need to shift it here, t to t minus a, and you have u of t minus a as well. Okay, that is the second one. And the third one, similarly, the third one will be 4 L inverse of e to the minus 4s divided by s plus 2, which means that this is a, right? This is a is 4, so you get L inverse of 1 over s plus 2, and then you shift t to t minus 4. Okay, and then you have u t minus 4. Okay, that's what you would have. Okay, so let's deal with term by term. So the second one, I would need to multiply it by 2 divided by 2, 2 fact, but it's the same as 2. So I pull 1 over 2 fact out, so I get 2 fact. Guys, I pull this one out here, so I get 2 fact divided by s to the s cubed, which means that it's actually t to the t squared, right? It would be t squared, and then change t to t minus 2, u of t minus 2. Okay, and the next one that will be 4 L inverse of 1 over s plus 2. L inverse of 1 over s plus 2. Guys, if you remember, if you take the Laplace transform of e to the at, that would be 1 over s minus a, right? If you take the Laplace transform of e to the at, that will be 1 over s minus a. Okay, if you don't remember, we can actually go back to the formula, which is here, but you should have it with you, okay, when you are watching this video. Okay, the Laplace transform of e to the kt is 1 over s minus k. Okay, so if we come back here, okay, I'll just change this to k, okay, but it doesn't really matter, it's just constant, but to use the same notation. Okay, so here s minus s plus 2 is actually s minus minus 2. Okay, so L inverse of s 1 over s minus minus 2, that would be e to the, what is it, minus 2t, right? Minus 2t, because here is minus 2. So s minus k, we get e to the kt. Okay, e to the kt. And then you shift k to k minus 4 and u of t minus 4. Okay, so here we have t squared minus 1 half of t minus 2 squared ut minus 2. Okay, and plus 4 e to the minus 2, and then you change from minus 2 from t to t minus 4, and then u t minus 4. Okay, and if you want you can write it like this. It would be t squared. If t is less than 2 and bigger or equal to 0. Okay, and it would be t squared minus 1 half of t minus 2 squared when 2 is actually, it's actually t squared minus 1 half t minus 2 squared u t minus 2 squared when t is less than 4. It's basically sum of this. Okay, it's basically sum of this. Okay, and it would be t squared minus 1 half t minus 2 squared u, sorry, there's no u anymore, plus 4 e to the minus 2t minus 4 when t is bigger or equal to 4. Okay, and that's it. But guys, in the exam, you don't need to answer in this form. Okay, you can just stop here, which is better, isn't it? Right? So if you get here, you just stop here. Okay, you don't need to split it into cases. Okay, but the reason I've been writing it here because I want you to understand the because you already know the unit step functions, right? So if I put it there, you should understand them as well. Okay, next question. This one. We want to find the inverse Laplace transform of e to the minus pi s minus 1 divided by s squared plus 9. Okay, so first you can see quite clearly that you have e to the minus pi s, which means that a is actually pi, right? E to the minus pi s, which means that a is actually pi. So this one, it can be written as L inverse of s minus 1 divided by s squared plus 9, and then you change t to t minus a, which is t minus pi, and then you need to have u of t minus pi. Okay, that is quite simple, right? It's a standard procedure. Okay, so now you need to deal with this Laplace transform. So let I use the big bracket here. So I will get L inverse of S divided by S squared plus 3 squared and plus, minus L inverse of 1 over S squared plus 3 squared. 9 3 squared, right? Right? And then you still have ut minus pi. Okay, but guys, here it's quite clear that it's s divided by s squared plus k squared. Here it's quite clear that it's k divided by s squared plus k squared. But you don't have k yet, right? So you need to multiply k divided by k. Okay, which means that I'll put k here and I'll put 1 over k here. Make sense? Because they can be cancelled out. Right? Right? So, but the k here is actually 3, right? So I'll put 3 here and then I get 1/3 here. Okay? So, here we would have that is the, okay, guys, we need to shift t to t minus pi as well. Don't forget that. Okay? So, L inverse of s divided by s squared plus 3 squared, that would be, what is it? It will be cos, right? Cos 3t minus 1/3 sine 3t and then shift t to t minus pi and then ut minus pi, and that would be cos 3t minus pi minus 1/3 sine 3t minus pi, and you would have ut minus pi. And that is the answer. You can just stop here. Okay. If you want, you can do it a little further, right? Because you know that cos of 3t minus pi is actually minus cos 3t. If you want, okay, if you want, it's gonna be minus cos 3t plus 1/3 of sine 3t and ut minus pi. Here we use the properties of trigonometric functions. Okay, and guys, I'm not gonna write it in cases, okay, because you can just stop here. You can answer in terms of use. Okay, you don't need to do this. You don't need to do this. Okay. Okay, you can answer in terms of use. Good. Good. Okay. Next example. This one. I will let you guys do it as an exercise. Okay. And we will look at that in the on-site class. Okay. It's quite clear, guys. It's quite clear. This, guys, it's quite clear that e to the minus as, right? Which means that a is actually a is actually half pi, right? A is actually half pi. And then, you just need to find Laplace transform of this guy. And then you shift t to t minus half pi, right? And then you have ut minus half pi. And the rest is the same. Okay? You try that yourself, okay? Okay, the last one, the last technique is the convolution. Okay, it's a convolution. Guys, if you remember, the convolution of g, f, and g is fx integrate fx gt minus x dx, or it can be gx ft minus x dx. Either is fine, because convolution of f and g and convolution of gf, they are the same, right? We talked about that in the second part of the second section. Okay, that's the third clip. So if you don't remember this, just go back there. Okay, so that's the theorem that we have if we have the Laplace transform of the convolution, it's actually just the Laplace transform of each of them, the multiplication of Laplace transform of each of them. Okay, that's quite convenient, right? You need to find Laplace transform of convolution of f and g. You just need to find the Laplace transform of f times Laplace transform of g, right? We did that before. And for the inverse Laplace transform, that is similar. That is quite similar. So here, I'm just gonna get rid of my video. Okay, here. If you want to find the inverse Laplace transform of f times g, that would be convolution of f and g, and that's integrate this one. And the inverse Laplace transform of f and g, it can be written as here as well, because convolution of fg and gf, they are the same, they are equal. Okay, so guys, whenever you want to find the inverse Laplace transform of two functions, the multiplication of two functions, is actually just the convolution of those functions. Okay, cool. Guys, let's look at this example. For this example, you can actually, go back and use the, the partial fraction, right? Try to split it into a divided by s plus 3 and b divided by s minus 5, and then you need to determine a and b, and then you apply the inverse term by term, right? Or you can use the convolution property, right? Here you look at 1 over s plus 3 as f, sorry, the big F, and then you look at 1 over s minus 5 is the big G. So this guy is actually f times g, right? So the convolution of that is actually f convolution of f and g t, right? It's just the convolution of f and gt. Okay, so guys, what is ft? What is ft? ft would be L inverse of one of the big F, right, which is s plus 3, and that would be e to the minus 3t. Guys, don't forget, here is s minus 3. Okay, L inverse of s minus k is e to the kt, right? Because L of e to the kt is s 1 over s minus k. Okay, so next we would find gt. gt is L inverse of 1 over s minus 5, and that will be e to the 5t. Okay, so f convolution of f and g, that will be integrate 0 to t f x gt minus x dx, and that will be integrate 0 to t fx would be e to the minus 3x, g of t minus x, gt minus x would be e to the 5t minus x dx. Okay, guys, gt is e to the 5t, so gt minus x is e to the 5t minus x. Okay, and guys, we integrate with respect to x, which means that t is actually considered as a constant, so we can pull t out. So here we would have e to the 5t integrate 0 to t e to the minus 3x e to the minus 5x dx. So we get e to the 5t integrate 0 to t e to the minus 8x dx. Okay, in that case, we would have here as e to the 5t and integrate e to the 8x, that would be integrate e to the 8x d minus 8x divided by minus 8, right? Integrate by substitution, right? Hope you guys can still do calculus 1. Okay, so you get minus 1 over 8 e to the minus 5t, or sorry, e to the 5t, and then you get e to the minus 8x from 0 to t, sorry, you get 0 to t. So you get minus 1 over 8 e to the 5t, and then you get, you substitute with t, you get e to the minus 8t minus 1. Okay, I'll just get rid of my photos. Okay, so we have, what is it? Minus 1 over 8 e to the minus 3t plus 1 over 8 e to the 5t. Okay, and that is the answer. Okay, I'm not sure, guys, which one is easier between this approach or this approach, but you should be able to do both, because some functions you might not need, you might not have the choice. Okay, you might be forced to use this technique. Okay, so whenever you see the multiplication of two functions, it's actually the convolution. Okay, so you need to find, the ft and gt of each of them, and then you just find the convolution of, those f and g. Okay, let's look at this question. For this one, again, guys, it would be fs would be 1 over s plus 2, and gs would be 1 over s squared plus 4. This one, again, you might want to apply the partial fractions, or you can use the convolution. Okay, so little ft would be the L inverse of 1 over s plus 2, and it's actually e to the minus 2t, right? 1 over s plus 2 is 1 over s minus 2, which is e to the minus 2t. We've done that quite a couple of times. Okay, so gt would be L inverse of 1 over s squared plus 2 squared, right? Because 4 is actually 2 squared, right? And then, guys, I can identify this as k divided by s squared plus k squared, right? So I need to multiply 2 and 2 here. So I would get 1/2 L inverse of 2 divided by s squared plus 2 squared. And that is actually 1/2 psi 2k. Psi 2t, my bad, sorry. Psi 2t. Okay, that would be 1/2 psi 2t. So this guy is actually the convolution of f and g, t, and that will be integrate fx g t minus x dx, right? And what is it? What is fx and gt minus x? That will be fx would be integrate 0 to t, 0 to t. Fx would be e to the minus 2x. Gt minus x would be 1/2 of psi of 2t minus x dx. Okay, guys, if you look here, you integrate with respect to x, so you can pull t out, right? You can pull t out. But guys, as you can see here, you have t inside, right? It's sine of 2tx. So if you want to pull t out, you need to use sine 2 theta first. You look at this theta. That will be 2 sine theta cos theta. And then you have, sine of t minus x. You need to have, I don't know, sine a cos b plus cos a sine b. And that would be really messy. It would be really hard to pull t out. Right? So if I were you guys, I wouldn't do it like that. I would just write this as g as integrate 0 to t gx f of t minus x dx. Because, guys, don't forget, f star g and g star f, they are the same. right? Convolution of f and g and f, they are the same. So integrate fx gt minus x dx, this guy, is the same as integrate gx ft minus x. They are the same thing, right? Right? And this is going to be a lot easier. Why? Because here it's going to be integrate 0 to t. Gx, it would be 1/2 sine 2x. See, we don't have t inside the side. And ft minus x, that would be e to the minus 2t minus x dx. And this one, I can pull e to the, I can pull t out, right? So I get 1/2 e to the minus 2t. Integrate 0 to t, sine 2t, e to the 2x dx. Okay? Okay? And guys, if you want to integrate this function, it just integration by part, isn't it? Right? You let this guy be u, and this is dv. Okay? Okay, I'm not gonna show that. Okay, I think you guys can do integration by part. Okay, if you can't, I explained integration by parts for the videos before midterm exam. Okay, so you can go back and look there. And if you still don't get it, just come and talk to me. Okay, but I'm not gonna explain it here because I assume that you can do integration by parts. Okay, so here the results would be 1 over 8 e to the minus 2t, and then you get e to the 2x sine 2x minus cos 2x, and then you get x from 0 to t. Okay, and that would be 1/8 of sine 2t minus cos 2t plus e to the minus 2t. Okay, it's quite simple, isn't it? Okay. Okay, next example, this one. Guys, again, I'll need to look at ft, the big fs as 1 over s squared, the big gs as 1 over s squared plus 1. Okay, and in that case, we have that ft is actually L inverse of 1 over s squared, which is t, right? It's t, because t to the 1 is 1 fact divided by s squared. Okay, that would be just t. And the other one, 1 over s squared plus 1. So gt would be L inverse of 1 over s squared plus 1. Okay, how to do that? You look at it as 1 squared. So that is actually k divided by s squared plus 1 squared, plus k squared. So here it's actually psi t. It's just psi t, isn't it? Okay, it's just psi t. So if you want to take the inverse Laplace transform of this, it would be just f star t. Oh, sorry, f star g t. And that would be, what is it? Integrate 0 to t ft g t minus x dx. But guys, again, gt minus x, you would get sine t minus x, right? And that's quite hard, isn't it? Okay, so we won't do that. We would use integrate 0 to t there will be fx gx ft minus x instead dx. Okay, so here it will be integrate 0 to t, gx would be sine x, ft minus x, that will be just t minus x dx. okay, and that is just integrate 0 to t sine x dx minus integrate 0 to t x sine x dx. Okay, and the first one is quite simple because you can pull t out, right? You would get just t, and integrate sine is minus cos, isn't it? And then you get from 0 to t. Okay, and the other one, it would be this integration x sine x. You need to do integration by part. Okay, you need to do integration by part. Okay, so you would have something, or actually guys, you can actually do integration by part from here. Sine x t minus x, right? You let u be t minus x, and then you let v be sine x dx. Okay, actually you don't need to split it like that, but if you want, you can split it like that. Okay, but guys, I'm not gonna show you how to do integration by part. Okay, so I'm just gonna give you the answer. The answer is t minus sine t. Okay, you can try integrate that yourself. Okay, this one is quite simple. It's as what I've written is t and minus cos x, right? And you let 0 and t. Don't forget guys, cos 0 is 1. Okay, and this one you do integration by part. You let x sine x, you get 1 0 minus cos, and then minus sine, and then you do the plus minus, if you remember the shortcut. Okay, and then you get that answer. Okay, this one I'll let you guys do it yourself, and then we will talk about that in the on-site class. Okay, everyone, and that's it for the inverse transform techniques. Okay, inverse Laplace transform techniques. I hope it's not too hard for you all. Okay, guys, in order to understand the inverse Laplace transform perfectly, you need to first understand the Laplace transform. Okay, you need to understand the Laplace transform first. You need to master the skills to do the Laplace transforms. Okay, look at the formulas, the formulas in the table, the techniques, and blah blah blah. Okay, and the inverse Laplace transform is just the opposite. Okay, so I hope it's not too hard for you all. Okay, and this is all for the inverse Laplace transform. Guys, what you need to do is do lots of exercises. Okay, I know, if you look at first, it looks quite hard, it's confusing, but you need to do exercises. That's how mathematics works. Okay, and guys, if you have any questions, just let me know. In the next video, we're going to be looking at the applications of the Laplace transforms. Okay, guys, so see you in the next video. Okay, and in the on-site classes. See you in the on-site classes. Okay, guys, don't forget to come to the on-site classes. We will have quizzes. Okay, and the road check as well, unfortunately. Okay, see you guys. Bye bye.